In April 2026, NASA's Artemis II astronauts are slated to loop around the Moon. Just 2 months earlier, in February, China pushed a Long March 10 prototype through maximum dynamic pressure, blasting off the pad to match the momentum. The United States and its partners built an early lead with the Artemis program's orbital milestones. However, translating those flybys into actual footprints on the lunar dirt is proving incredibly difficult. Artemis 3, the mission designed to put humans back on the surface, is currently navigating severe technical hurdles. Official schedules have pushed the landing to 2027, with safety panels warning that technical bottlenecks could force even more delays. By contrast, the Chinese lunar exploration program has entered Phase 4. They've set a rigid deadline to land their crew on the Moon before 2030, and the physical hardware required to execute that mission is already rolling out for testing. The 21st century lunar race has moved beyond hypothetical projections into an active, dual-trajectory competition where schedule certainty is battling ambitious innovation. The Western architecture relies on the Space Launch System, or SLS. It is a massive vehicle, producing over 3,700 tons of thrust at liftoff to muscle heavy payloads toward deep space. But getting into orbit is only the first step. To descend to the lunar surface, NASA selected SpaceX's Human Landing System, a specialized, highly capable version of the Starship prototype. Starship's size means it cannot reach the Moon on a single tank. It requires in-space cryogenic propellant transfer, connecting 2 spacecraft in low Earth orbit to pump super-chilled liquid fuel between them, a technical feat targeted for 2026. China's approach bypasses orbital refueling entirely, instead using a simpler method known as two-launch lunar docking. One Long March 10 rocket sends the lunar lander into orbit around the Moon. A second rocket launches the crew capsule. They dock in lunar orbit, and the crew transfers over to head down to the surface. Program development for all of these Chinese vehicles is already complete. They have moved straight into the testing phase, recently verifying their crewed spacecraft design with a high-speed abort simulation. NASA is risking schedule slippage to field a massive, highly capable landing system. China is relying on simpler, proven architectures to protect its 2030 deadline. This chart tracks NASA's inflation-adjusted budget from the Apollo era to today. The 2026 proposal brings their purchasing power to its lowest point since 1963, right before the original moon landings. Beyond the agency, federal cuts to non-defense research have stalled the scientific ecosystem supporting lunar exploration. By comparison, in 2025, Chinese commercial space companies pulled in a record $3.8 billion, driven by regional governments financing aerospace manufacturers. They are actively pouring that capital into batch production. Manufacturing is scaling up to treat rockets as mass-produced commodities, and the Wenchang spaceport is expanding its infrastructure to handle dozens of launches per year. Sustaining a lunar program requires predictable, long-term financial momentum. As the U.S. navigates its tightest budget environment in decades, China is rapidly scaling its state-backed industrial base to protect its 2030 landing window. Both programs are currently building towards the same objective: established permanent infrastructure on the lunar surface. This has fractured the globe into 2 distinct coalitions. Over 50 nations have signed the Artemis Accords, aligning with the United States. In response, China and Russia are leading the International Lunar Research Station project, bringing in partners from South America to Africa. To prepare for their base, China has a strict schedule of robotic precursors. Chang'e 7 and 8 are scheduled to launch in 2026 and 2028 to scout the resource-rich lunar South Pole and lay the physical groundwork for their station. The Artemis Accords rely heavily on shared principles and diplomatic agreements. China is using its robotic missions to offer its international partners tangible, physical access to lunar infrastructure today. If SpaceX and NASA successfully execute the orbital refueling and Starship development, the United States will maintain its edge and land first with more payload than anyone else in history. But if federal budgets keep shrinking and engineering bottlenecks stall the Artemis timeline, the math begins to favor the competition. China does not need a technological miracle to put astronauts on the Moon. They just need to keep iterating on the hardware they already have, fueled by a reliable pipeline of capital. The 21st century space race is a definitive clash between Western innovation and Chinese iteration, hurtling toward a final convergence at the lunar South Pole.